Hi friends, welcome back. Till now we learned about all the concepts using first law of thermodynamics. Is first law gives all the information of the system in thermodynamics? What is the answer? The answer is no, because the first law won't give any explanation about spontaneity of the system. You don't know whether the system is spontaneous or not. So to know the system randomness, we need another law. The law is second law of thermodynamics, another important concept of thermodynamics. So let's begin the session. Hi friends, in the previous part we have discussed about the limitation of first law of thermodynamics, right, and the need of second law of thermodynamics. So what is second law of thermodynamics? What does it gives me? Second law of thermodynamics helps us to predict whether a given process or chemical reaction is spontaneous or not. So second law of thermodynamics gives me an idea about spontaneity. So it tells me whether a given process or a given reaction can be spontaneous. And what else comes into the picture? Feasibility, right? So second law also gives me an idea about whether a given process is feasible or not, right friends? And the whole process of second law of thermodynamics is defined in one of the most important parameter, which is entropy change, right? The feasibility or spontaneity of any process or any chemical reaction can be defined with another important term, entropy or entropy change, right? So entropy gives me an idea about feasibility and also spontaneity, right? So what is entropy change? Entropy change is also a state function. Entropy also a state function, right? So it gives me an idea about feasibility, and it is the ratio of heat change in a reversible process by the temperature, right? So change in entropy is equal to, in a reversible process, change in entropy is equal to the ratio of heat change by temperature, right? It can also be written as delta Q by T. So this is what entropy change is, right? So this we in the earlier slide we are discussing about in a reversible process, right? Now what happens in an irreversible process? In an irreversible process or in a thermodynamically irreversible process, it is always accompanied by increase in entropy of the system and the surroundings taken together. So in an irreversible process, right, the entropy of the universe is nothing but the combination of system and surroundings increases, right friends? So in irreversible process, the entropy of system and surrounding increases, or the entropy of the universe increases. And what else the important point is, right, in a thermodynamically reversible process, the entropy of the system and surroundings remains unaltered, right? So the entropy of the universe in a reversible process, it will be unaltered, that is change in entropy will be zero. Here change in entropy will be of universe, right? When I am writing change in entropy, it should be change in entropy of the universe, right? Change in entropy of the universe will be greater than 0, and these are the two important points, very important points, right? Now let's learn about physical significance. What is exactly the physical significance of entropy? As I already told you, right friends, I told you entropy is nothing but it is measure of disorderedness, right? When I told you entropy gives me an idea about spontaneity, it gives me an idea whether a given process is spontaneous or not. Simultaneously what is happening friends is entropy is giving me an idea of disorderedness, right? Why? Because spontaneous process are accompanied by increase in entropy as well as increase in disorderness of the system. So any spontaneous process, friends, in this universe, you can take any spontaneous process like rusting of iron, right? So any spontaneous process, friends, it is accompanied by increasing in entropy. How the entropy of iron is increased? Because of rust, right? Rust is nothing but it is a symbol of disorderedness. Rust is a symbol of disorderedness, right? That means entropy is increasing. Entropy is increasing, that is disorderedness is increasing. So in this universe you can consider any spontaneous process, right? You can also consider another example, decomposition. Decomposition of any substance. Consider an apple, right? An apple decomposed. What happens, friends? The disorderedness increases. The disorderness increases, right? It will be filled with bacteria and fungi, right? And release of smell. So there is a disorderness in the given system. So this is also a spontaneous process, and the system, the final state of the system is in a disordered state, alright. So what is the important point you have to understand, friend, here is entropy is a measure of disorderness, right? Entropy is a measure of disorderness. Why? Any spontaneous process in the universe is accompanied by increase in entropy, just I already told, as well as increase in the disorderness of the system, right? So this implies that increase in entropy implies increase in disorderness. So this is the physical significance of entropy. So friends, these are few important points of second law of thermodynamics. We have seen how entropy plays important role in thermodynamics. So in the next part, we will learn some more interesting parts of entropy and disorderedness. So keep tuned, friends. Have a good day. Goodbye.